Hey everyone, so this is the probably the 40th video I've created of this. Now I think I've got it straightened out. So here's the results. So we have here a Newport Engineering windshield wiper motor for my 1958 Edsel. The original Edsel had vacuum windshield wipers, and it had a switch on the dashboard that you would adjust just like this, up and down, and that would adjust a vacuum port, which would allow more or less vacuum to be used by the windshield wipers. Vacuum on a car is variable, so if you're going uphill and you accelerate, then your vacuum goes away and then your windshield wipers don't wipe. So on things like hills, on a good rainy day, you could essentially be left with zero visibility for quite a long period of time until you let off the gas and regain your windshield wipers. So we've switched to electric, but the Newport Engineering motor has only two speeds, low, high, and then we have a park wire. So when high gets 12 volts, obviously it goes really fast. When low gets 12 volts, it gets a little bit slower. And these are exclusive of each other, so you can't have low getting 12 volts and high getting 12 volts. It's one or the other. And same with park. Park has to have its own 12 volts, with high and low having 0 volts at the time. So these are positive wires. The housing here is grounded. So what I've done is I've cut into the grounding and I've taken a wire outside of it, so that way I can isolate the negative wire and do what I want with it. That might not be necessary. So what I have here is an Arduino Uno with a Cytron Shield MD10 R2 on it. Now this is a really great setup because this shield is a hat that pops right on top of the Arduino underneath. And then I have this powered by a buck converter, which converts the 12 volt input coming from our live wires to a 5 volt output that the Arduino can use. So my 5 volt connection goes straight to this wire here, and then it goes to the common ground, which is going through here. So this gets grounded through the Arduino as well. The negative wire comes out of here, right? So that's coming from our battery source, 12 volts, and goes into this bundle here. One leg goes to the motor. The other leg comes over here and goes into this connection, which goes to our motor controller and our buck converter. So that's how that splits out. You'll wonder what I have going on here. So why do I have two diodes that are going to our motor input? Well, we only need one leg of the motor connection going to our motor. And the reason for that is because the motor is actually driven on the positive side. So the positive side is basically the connection that limits the amount of power going through. And the negative side has a ton of power. It has 12 volts of power. So this side can say, well, I only need 5 volts, so only give me 5 volts. And that's kind of how that works. The diodes prevent any power from going back the opposite direction. So it's only coming out this way, or actually going, yeah, it's only going this way towards the motor. So when this says I need 5 volts, it's only supplying 5 volts, and it can never get 12 volts from, say, this leg over here. So what I could do is, because I only have 2 wires and both of them need positive voltage, I could actually run one motor controller with one input, or one motor connection, have 2 diodes, and these are 10N10 diodes. Let me get the numbers on that real quick. If I can open up this new case. Those are 10A10. So 10A10 diodes. That is a, oh no, I'm sorry. These ones are not the 10A10s. These are 1N5822s, if I remember right. Yep, 1N5822s. You could also use a 10A10, but basically a 1N5822 is a 40 volt, 3 amp diode. A diode can take a little bit more than 3 amps, but we are running about, let's see here, at full speed, 1.5, 1.6 amps. Obviously with a windshield wiper attached to it, it's going to be more, so I might switch these out to the 10A10s. And just so you know, the 10A10 is a 10 amp, 1000 volt diode, so it can handle as much power as I could possibly give this. This motor controller is a 10 amp motor controller, so again, this motor controller can handle the load, so I'm not worried about that. We have a fuse in the car that's, I believe, a 10 amp fuse, so we should be good there. But this is all modular too, so if one of these systems does burn out, you could change it out. It's just a motor controller. So hopefully that works out. And again, the way that this works is when I need it to go into high speed, or when I need it to drive the motor forward like it's doing, I provide a speed and a direction, and the direction is forward in this case. So that supplies this with power, and that can be anywhere from 12 volts to 0 volts if I wanted it to. It's PWM controlled, so I could just tell it, from 0 to 255 is the value, 128 is half speed, 255 is full speed. So that gives me kind of a variable speed controller here. Now this one is my park wire, and this one gets full speed, so full 12 volts, and this one gets 0 volts. So what happens is when I reverse the direction of this motor controller, voltage is coming out here, going that way, but it can't go this way. So this motor, or it can't go this way. So this motor wire is not being activated. It's not being used as a ground, and then this one is being used as a ground. So that's kind of how that works. Basically, this is not connected, and the reason why that's that way, it's hard to explain. But basically, there's a number of coils in here, which the coils are connected to our ground wire, and then when I reverse this without these diodes, then this guy here supplies power, or this guy here supplies power, and you just get it running all the time. So with the diodes, I can isolate the power and only have it go in one direction, and then I can flip the circuit back and forth between running backwards or running forwards. And when it's running forwards, I just make the speed variable, and then when I run it backwards so that I can put it into park position, I increase the speed to 100%, and that will eliminate the voltage going to our high wire because of this diode. The diode won't allow electricity to go back the wrong way. So that is how that works out. It's really great. Oh yeah, and these will actually, if I don't have the diode in correctly, then it'll stop the motor because we have, one telling it to go backwards, the other telling it to go forwards. So this is kind of a unique solution. I tried everything. I tried doing relays to switch the connections from this one over to this one. When this one got too low, it would detect the voltage, and then it would switch it to the normally open position, and this one would get power. But that didn't work, because as soon as this one got power, or as soon as this one turned off and this one supplied the power, then this one got power, and then the motor acted funny. So I couldn't do that. I couldn't use transistors. I tried using these types of relays, thinking that an optocoupler relay would work better. I tried using an Arduino with these, but an Arduino can't switch these on properly when the motors are connected, because somehow we're getting negative feedback voltage from one of these sources. So this guy didn't work, and I realized that diodes are really the only way to go, and a real Arduino and a real motor controller is the only way to go. So the next step here is I need to create a box for this. I need to wire this up properly. I need to wire that up properly. I need to get this integrated with the Arduino and program that. But I'm really happy about this. So this is showing full speed. After 5 seconds, it switches to 3/4 speed. And after 5 seconds, it switches to half speed. And another 5 seconds, it switches to 1/4 speed. And then it switches to park position. So if it's over here, then it'll go back and it parks itself. Funny enough, if it's over here, then it won't park itself because it's already in park. And that shows a full range of motion. It shows how the speed can be absolutely controlled now, and that's great. Now I just need to figure out a way to get the original wire connected to something like this. So yeah, fun times. Thanks.